Hello, my name is Muhammad Hafiz bin Sulaiman. Matic number DE210044. Okay, today we will show our group project for assignment 1 for microprocessor and microcontroller. This is my group member. First one, Muhammad Haris bin Samri, DE210053. Muhammad Hafiz bin Sulaiman, which is me, DE21004. Muhammad Zamani Amni bin Muhammad Zani, DE210048. Brian Jordan Wilfred, CE210035. And the last one is Usama Abdirizak Muhammad, AE 200096. Okay, I will pass it to my next member to present about the introduction for our assignment.
Hello, my name is Usama. Abdirizak Muhammad. My matric is AE 200006. Here is our project Microprocessor role. Assignment 1. We're from group 6. Actually, we have 5 group members, which is Muhammad Haris bin Samir, Muhammad Daniel Hafiz bin Sulaiman, Muhammad Zamni Ayman Amni bin Muhammad Zaid. And we have also Brian Jordan Wilfred. Our table contains introduction, closure, assembly code, result, and also discussion and conclusion. Today I'm going to present introduction. Memory, the storage space for the data and instruction is divided into main regions: program, memory, and SRMA, programmer memory, also known as a ROM. Holds the program code that the CPU executes. It's a non-volatile retained with a content is given when power is lost. SRMA, volatility of memory storage data during program execution and offers faster access times, but losses content is when power is lost. Assembly language, a low-level programming language, provides direct control over the computer hardware, and it's enable programmers to write instruction that manipulate registration memory location. And arithmetic operation is assembly language particularly useful in embedded system programming, where resource optimization and direct hardware control are crucial. In embedded system programming, copying data from program memory (SRAM) is often necessary to leverage SRM's faster access speed improvement program performance. This is particularly important for the time critical applications like motor control, where the motor control code is needed to be transferred to SRM before initiating motor operation for the efficient and responsive control. That's all for me, but
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Zamri and my number matric is DE210053. Alright, so for today I will explain about the flowchart that we use for that to assembly code for the assignment that we get. Alright, so this is the overall overall flowchart that we use. So as like you can see, we use first we use start, which this is to indicate the start of the program. After that, we use a process block to initialize pointer for SRAM. So this is set up a memory pointer for static random access memory, which is we call SRAM. SRAM is a type of volatile memory use for data storage. And then we go to initialize counter 26, which is this is initialize counter alphabet, that we have a 26 alphabet. And then so this counter might be used in a loop structure for iterating through the alphabet data. So that we have to use to see at loop. So after that, we use again a process block, which is initialize hex data for uppercase letter alphabets in program memory. Alright, so we use alphabets of uppercase letter in program memory. So this counter use this count eh, this step involve loading the hexadecimal representation of uppercase letters into the program memory. This data will likely be accessed during the data transfer loop. So what I say is loop is this. So as you can see, this one. So right, so we use a diamond shape for the decision yes and no. Alright, if counter more than 0 is mean yes, so it will store alphabet data to register. Alright, so this as you can see, it loads the alphabet data into a register, which is after that we use a code to to uh to the to go to the SRAM. So it will copy that alphabet before go to SRAM, and then it will store alphabet that we use to data to SRAM. So it's move the address pointer to the next location containing alphabet data, and then counter again, and it will go loop again if counter more than 0. Alright, and then it will go to this until it have a 26 uppercase letter. So and then uh, if the if r if counter is less than 0, so it mean it will know, and the process of to copying the alphabet from register to SRAM is end. So which is we know that uh, the loop not will continue, and it's a conditional branching statement, and it will mark the end of the program.
Hello, my name is Brian Jordan Wilfred and my matrix number is CE210035, and today I will show the code listing for our group assignment. Okay, so I will jump straight to the main. The first one over here is to set the address of the SRAM, which is 1000 to FFE. We are using move wide and move top because if we use the move, the code will produce an error. So we use move wide to store the value of 2 FFE to the bottom of the register, and then we use the move top to store the value of 1000 at the top of the register. Okay, and the next is this one. Load the address of alphabet over here into the register of R1. Mind that this value over here is not the value of the hex of uppercase letter, but instead it is the address that we store into the register of R1. Next, we will using the register R2 for the counter with the immediate value of 26, because we know that the alphabet have 26. And then next we will go to the loop. The first one is LDRB, which is to load a byte to the register R3 with the address of R1, which is over here, alpha, and then we will increment the address of R1 by 1. So for example, if this address over here is value at 100, and then this one over here will increase the address, which will point out to the next, which is, for example, 101. So next is strb, same as before. B is for byte, so we will store the data from the register R3 into the address of R0, which is over here, 1002 FFE, which is the address of SRAM. And also we will increment it. So from 2FFE, it will go to 2FFF. So the next one is subs. We will decrease the number of 26 inside the register R2 by 1. And then it will decrease. So from 26, it will go to 25. And then after that, we will use the instruction of CMP, which is to compare into the register R2. So if the register R2 is more than 0, it will continue loop. Otherwise, it will branch out from the loop and then end the program. So that is all from me. Thank you very much.
Hello, and my name is Muhammad Daniel Hafiz bin Sulaiman. Matrix number DE210044. I'll continue for the result in order to get the R3 and R2. So we run the code by clicking the start or stop debug section, enter OK, and after that we go to assembly 1 and pick the cursor line that we want to run. Okay, from here, if we want to run the data from here, we just need to click the step and it will run it step by step. This assembly is for the program counter. Program counter is at here R15, and this is the arrow. So when the arrow point at this, it will run for the store data alphabet to SRAM. And you can see here, and on R3, and then we run the next step by doing the subtraction for the R2. It will subtract one counter, and we can see here the R2 will from 1A, it will down to 19 because of the subtraction. And then if the value for the R2 still bigger than 0, it will do the loop data. We just enter here, and it will program counter will loop to load the data from R3. It will loop the data and enter the value into the R3, load, and then it will store data to the R3, which is here 42, and then the data will be enter the memory 1, which is the SRAM, and it will continue subtract the R2, and it will loop again. So if we continue to run the program counter, the value for the R3 will increase one by one, which is here. We can see here it will adding one value, and for the R2 will be subtract by one value. So what will happen if we continue to run? You can see here. So the value for the SRAM will be continue until it reach 5A, and then for the value at R2, it will decrease until it reach 0 and cannot be looped again, and it stop the loop process. Okay, we will see if it's true or not. Okay, if we continue to loop and enter the value inside the SRAM, then 59 5A. Okay, we will see here for the R2, it will become 0 when do the subtraction. You can see, okay, here R2 is 0, and then it will stop the loop, because if R2 0, it will not loop again. You can see here. Okay, so we have done our simulation. R2 will become 0, and for the R3, it will reach 5A, and it will stop the counter. Okay, that's all for me today. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaman Amni bin Muhammad. I am from Group 6, Microprocessor and Microcontroller, and I will present about the conclusion for this report. Okay, in computer system, storing data in program memory, reading from program memory, and transferring data into SRAM are essential operation for the computer. They are essential to the operation of the system as a whole, data management, and program execution. Inserting data into a non-volatile memory location that endures even after power is turned off is known as program memory storage. Prerequisite static data for program execution, such as constant and instruction, usually make up this data. During program execution, the stored data must be retrieved to read data from program memory. Program memory is accessed by the CPU to retrieve this data and instruction for processing into its register. Okay, CPU can carry out the intended operation and execute the instruction. This process is essential. Data is a from program memory or other memory location that are moved to SRAM, a volatile memory that retains data as long as power is applied. Because RAM operates faster than other forms of memory, this is frequently done to increase performance of computer or software, or computer system or software. System responsiveness can be greatly improved, and data access time can be greatly decreased by moving frequently accessed data to SRAM. The use of these apps QL Uvision 5 in answering to the PBL question that have been given has a positive impact on students to better to understanding how to store the data in the program memory, read from the program memory, and move to SRAM from the memory address that has been given, which is 0 multiply 1000 to FFE. Okay. In summary, developing effective and dependable software and hardware system requires an understanding of the procedure for putting data into program memory, reading data from program memory, and transferring data to SRAM. These functions are essential to program execution, data management, and system performance as a whole. Okay, that's all from me for our group presentation. Thank you very much.